All right, folks, welcome to Barley Bin Live. So we're really excited to be here. We're at the Dam Smokehouse in Nipawin. I don't know about you, but my first time here, it was an excellent meal. So shout out to the staff here at the Dam Smokehouse. Also want to give appreciation to everybody who took time out of their schedules to be here. We've got speakers who've come from a long ways away, Saskatchewan, Indian Head, and Lacombe. And we've got everybody in the room here tonight, so appreciate you taking the time to come in and hear a little bit about barley tonight. First topic tonight is I think one that'll generate some excitement. New variety acceptance is sometimes a little bit slow in the malt industry, but as I mentioned, we're at a transition period right now. I think even on the feed barley side, which I didn't necessarily expect, we've seen a slow transition there too. The current top variety in the feed world is CDC Austenson, and it's been there for a long time, but it's been a tough variety to top. But I think Aaron can probably talk a little bit about some varieties that are very close to market or just into market that I think have the potential to topple CDC Austenson from the top of the feed market. So. First question to Aaron. We've got a map of the barley genome. Gene editing has recently had the reins loosened by the Canadian Food Inspection Agency on its use in breeding in Canada. What are the possibilities that emerge for barley from these recent developments, either individually or collectively? What's your perception of the market risks of using it? And how would barley fit in the overall crop choice for growers if we don't use the tools available? I'm going to ask the second question as well, just so Aaron can have the mic and he can roll with it. So Aaron, you see the barley line's performance from the initial cross to the Western Canadian field trials just leading up to registration. At what point do you get excited about a line or new variety? And what new traits are you seeing in the pipeline?
Okay, so question one here. So I think this is a huge question, and Mitchell said I've only got 10 minutes for each one. So I probably need to give you a little bit of background just to kind of maybe set the stage on this. So as you may or may not know, in the last 25 years, we've heard a lot about sequencing of genomes. And the first one you might have heard about was the human genome. So that probably goes back about 20 years now. The crops sort of followed on from those developments that we learned about how to do it in the human genome. And so barley, about 2012 was the first year that we got our first sort of look into what the barley genome looks like. And that was in one particular variety, US variety that was called Morex. So quite an old variety, but it was the one that got chosen to do the sequencing on. Since that time, there's been quite a number of other genomes that have been sequenced. In fact, just in the last few months, there was a consortium of workers that released 75 genomes. So that means 75 different barley varieties have been now sequenced. And so that's a big body of knowledge that we potentially now can take some use of. So if I kind of step back in time before we had all this information, just to give you a bit of an example of how we maybe go about things and how these genomes can maybe help us out. Since Kelly's in the room, who's a pathologist, I'll use sort of him as an example. So if I was interested in scald resistance in my barley variety 30 years ago, really the only way that we could do that is I would have to send Kelly some of my breeding material. He would grow it out in a field. He would inoculate it with the pathogen that causes scald, and we'd figure out pretty quick if we had resistance or not. So as we kind of move forward in time, we were able to use some of the tools we had at the time, genetic tools, that would allow us to identify roughly where those genes are in the barley genome. We didn't know exactly, but we had an idea. And so if you hear people talk about molecular markers, that was sort of the technology we have. A molecular marker basically tells us roughly where in the genome a particular gene is that controls a trait. So if I was again talking about scald resistance, we'd have markers linked to those genes, but they weren't perfect. So there was an error rate. So if I was selecting a barley line that had a marker that was linked to scald resistance, I would be pretty sure that it actually did have scald resistance, but there might be a 10%, maybe a 15% error rate, which would mean actually it wasn't resistant. So with these genomes now, we can get very detailed in terms of understanding which genes control what traits. So now my error rate goes down to almost nothing if I can figure out exactly what gene is controlling the trait. So with these genomes, we can start to, with some background research, figure out what genes control what traits. And as a breeder, I can start to incorporate that information into how I do selection. So I don't necessarily now maybe need to send all of my material to Kelly's nursery. I can do some work selecting for these traits based on these markers, which are now very accurate because they are actually now inside the genes that control the traits. And so moving forward, as we kind of pick new traits that are of interest, maybe it's lodging resistance, maybe it's malt barley quality, we now have 75, 80 different genomes now that we can look at to understand how much variability there is for these characteristics. So again, if I was interested, say, in protein content, I might be able to narrow down the region pretty roughly using some of our old tools. But now with all these genomes, I can now say, okay, well, we think it's in this part of the genome. What genes are in that part of the genome? I can look across these 75 different barley varieties. And if I measure protein content in them, I can pretty quickly determine, based on the genes they have and the variation in those genes, if I've actually got the right gene. So again, as a breeding tool, this is very useful for me. And we already are making use of this information in our program. So that's kind of the background on the barley genome. And where gene editing comes in is that gene editing basically relies on having information about the genome. So if you didn't know anything about the barley genome in this case, gene editing basically is a tool that's unavailable to you because it relies on knowing two things. It relies on knowing the sequence of the genome, but it also relies on knowing what genes control what traits. So again, if I was looking at if I knew a particular gene controlled a particular trait, I can use gene editing to alter that trait, hopefully in a beneficial way. So you still need to do a lot of background information or background research to figure out what genes are controlling what traits. Gene editing then may allow you to alter that gene in a way that is beneficial to you. So gene editing sometimes gets played up as this magic tool that's really going to propel us forward in all types of crops for all types of traits. I probably don't see it quite that way. There's still a lot of background research required before you can actually use that tool. So if a trait comes along that we're interested in, or even some of these older traits like lodging, if we don't understand the genes that actually control those traits, gene editing has no value to us at all. The other thing about gene editing is it tends to be most useful for traits that are controlled by one or very few genes. So some diseases fall into that category, some quality traits fall into that category. But for the most part, yeah. Better? Same. So most of the traits that are of most interest to us, yield, probably FHB if we were talking about barley, these are traits that are controlled by a lot of genes with very small effects. So gene editing is probably going to have no impact on those kinds of traits. And when you look through the literature about what traits have been brought forward and commercialized, there are things like sulfonylurea resistance in canola. It might be increased fiber digestibility in alfalfa, which is a single gene trait. In crops like apple, I think that's got it, yeah. I think in crops like apple or potato, they have these so-called non-browning characteristics. Again, these are single gene traits. This is where we're seeing gene editing having its initial impacts, and I'm a little doubtful that it's going to have a lot of value to us as we move into the more complexly inherited traits. So it's an interesting tool, but it's just that. It's just a tool. And it kind of takes over from what breeders have been doing for a long time. So it's sort of the precursor to gene editing is what we call mutagenesis. And mutagenesis is just this simple way that we used to alter plants to try to find characteristics that we cared about. So for example, if I wanted to find a semi-dwarf barley and I didn't have it, I might take a bunch of seed of my favorite variety. I might treat it with some sort of chemical agent that causes mutations within the genome, and then I would go out and look for shorter plants. So I didn't need to know what genes controlled that trait. It's basically a shotgun approach to it. So you know that many of the mutations that get induced are going to have no effect on the trait that you're interested in, but some of them will actually impact it. So gene editing is just a little bit more of a precise form of mutagenesis. The caveat being you actually need to know what gene you're changing. So it's got a good side, it's got a bad side to it. So maybe that leading into the second question, are there still market risks? So there's been a lot of debate about initially where gene editing fits into the whole genetically modified crops discussion. And so some recent changes with CFIA has basically said that gene editing should be thought of as basically like mutagenesis. It's not quite a conventional breeding tool, but it falls into that category of tools that breeders have at their disposal, which will get regulated a little bit differently than a genetically modified crop. But there are caveats to that. And so Canada, this is where there's a little bit of background information required. So in Canada, we've never really regulated a crop based on how it was created. So we have a term in Canada that we call plants with novel traits. And basically that's just saying that if a plant that you create through breeding, no matter what the process, is significantly different than what's already out there, then they're going to call that a PNT, and it's going to fall under some regulation where they look at how the impacts or the potential impacts on food safety, feed safety, and on the environment. And so that definition is troublesome because you may not always know what is going to be captured by that PNT description. So to give you an example, about 10 or 15 years ago, we had done some work, or my predecessor had done some work, where Brian Rosnagel had created a new barley that had altered levels of a compound in the seed called phytate. So phytate is just a storage form of phosphorus in the seed. This was done through traditional mutagenesis. But CFIA flagged it as a PNT because the amount of phytate in that seed was very different than sort of normal barley. So that would have sort of kicked off a long round of assessment both for environmental and food safety, which is probably a 10 to 15 year process. You're talking about tens of millions of dollars there. So even though gene editing isn't quite the same as transgenics or genetically modified organisms, there's still the potential that if you create something with this technique, it could still fall under this PNT category, which has always been there in Canada. So it's a little bit better than genetically modified organism because those automatically fall into being regulated. With gene editing, it really depends on what you've done to the plant there. So that's maybe a little bit on sort of what it means. And in terms of market risks, again, now this is just where you're getting into the thinking about, well, how are consumers going to feel about this whole technology? And so in the science community, we may feel that there are meaningful differences between a genetically modified organism and something that's been gene edited. My sense, if you talk to people who are not science-oriented folks, is that they're not going to really see a difference between these two things. They're going to generally see that some kind of manipulation has happened. And if this change that you've put into the plant doesn't really benefit a consumer directly, it's just as easy for them to say, no, I don't want that. So I still see a lot of market risk associated with this. And I think the barley community in particular, especially the malt side of the industry, being quite a conservative industry, they're always going out to their customers, the brewers, and sort of soliciting their opinions on these sorts of topics. And I don't think gene editing is really going to be much more of an appealing topic to them than genetically modified crops have been. because they're going to be worrying about their consumer perception. And that's a hard sell. I mean, I think even if you're talking about a trait that may improve this whole big topic of sustainability, where you think, okay, well, maybe there'll be a play with the consumers. If you can say I can grow that crop with less inputs, maybe there's a sell there. I'm still not sure if that's a strong enough pull from a consumer point of view. And just to give you an example of that, in Canada, there's a company called Okanagan Specialty Fruits, and they've created this line of apples, which they call Arctic apples, and basically they're these non-browning apples. So that basically means if that apple gets banged or bruised somewhere along the way between harvest and when it reaches the store, normally that's going to cause some browning. Consumers tend to shy away from apples that are browned off, even though there's nothing wrong with them. So there's a huge food wastage component to the apple industry. So these non-browning apples are trying to deal with that eye appeal, which would prevent consumers from just throwing away or not purchasing these apples. They haven't, and so when the company started down this path, they talked to consumers about this, saying, like, if you had a genetically modified crop that was dealing with this issue, and they told them about the wastage, is this something that would interest you? And at the time, they got fairly positive feedback on it, but if you look at where that's gone in the market, it's a very small uptake of that product. So there's at least in my mind, it's an example of probably a great idea, and it saves a lot in terms of food wastage, but the uptake, because people know it's genetically modified, has been extremely small. And so I still put gene editing into that same pool, at least within the general public's mindset. So I still see market risk for using this technology. And then just for the last point there about what happens for barley fit if we don't use it. Again, like I said, I don't think it's a game changer technology to start with in the first place. There are other ways we can get to the same point using other technologies which are maybe less controversial. So I don't see it necessarily as a negative if it's not being actively used to produce varieties. We certainly use it. We use it in our own program to study genes in barley so we know what they do. Our strategy is to do that and then go look for, once we figure out what it's doing using CRISPR, we can go out into the natural germplasm pool of barley and try to find basically the same characteristic. That's kind of our approach on using it. So it's a great research tool. It tells us a lot about what's going on in barley, but then actually, taking that information and translating it into varieties, we've got other ways that we can basically go about that. So that's kind of my quick take on CRISPR there. Do you want me to do question 2 at the same time here? Okay. Okay, so again, maybe a little bit of background on this one. So in Canada, it's pretty typical for a variety to take probably 6 to 8 years within a given program to kind of make its way from initial cross all the way to something that a breeder thinks is good. And then tacked onto that in Canada, we have a 2 to 3 year registration process. So basically that's a system where, depending if it's malt or feed, the barley is grown across Western Canada in a cooperative, very public system. And at the end of those 2 or 3 years, the varieties or the potential varieties are assessed on their agronomic performance, disease, and their malt package. It's voted on. Essentially, it's voted on by a team of experts that cover the entire barley industry, pathologists, breeders, cereal chemists. And if that potential variety is deemed to have merit, so merit meaning is it better than what's already out there that farmers already have access to, then it can be commercialized in Canada. So altogether, that's maybe about a 10-year process. So when Mitchell asks, at what point do I get excited about a line or variety? That's probably at least it. So if I was to say that, in our program, maybe it's 6 years that it takes from cross to finish, probably around year 5 would be the first time I might start thinking about a line having some potential. It's at that point in the breeding process where we're actually able to get some yield information on it. We're actually able to grow it outside of Saskatoon in a number of the provinces that neighbor us. So we get some idea of adaptability. And then if it's a malt variety, that's where we're going to get some sense of its malt potential as well. So, but that's early days. It's 1 year. And as you know, year to year, you can't really rely on that being very predictive of what's going to happen the following year. So the very last year in our program, we get it out on a few more acres, a few more fields. And then, the excitement can build at that point. So that's probably about when you start to get an inkling if something has potential. Probably more often than not, you were wrong. And the subsequent years will show you that it really wasn't that good. But when I look back at the varieties that we have now and when I started sort of making a note about them, that's probably about typically when that was happening there. And then in terms of new traits in the pipeline, new traits are hard to come by that really sort of wow people. So probably, we're talking about improvements of traits that are out there, or at least putting them all together into one package. But one trait that I would maybe mention here, and it's come up in the last few years, but certainly if you're a malt barley grower, you've come across this issue of pre-harvest sprouting being a big issue. And so if you're growing some of those higher enzymatic varieties like Connect or Fraser or Prairie or back in the day Metcalf, those varieties would have had a little bit higher tendency to sprout on you compared to, say, a Copeland, or maybe these days you'd think about a Churchill. And that just has to do with the enzymatic potential of those varieties. So probably if you're growing a Copeland or Churchill, you're probably in a bit of a safer zone in terms of not seeing quite as much pre-harvest sprouting for the same amount of rain or humidity that you may if you were growing one of those other varieties in the next field. So one of the things we've been trying to work on is in those higher enzymatic varieties is trying to identify that really high level of malt quality that you would come to expect with those varieties, with tolerance more like Churchill or Copeland levels. So we've got a few different ways that we do that, and I think right now we've got some material, especially one line in particular in the co-ops, that's looking like it's captured that combination of traits. So I think, down the road when we're sort of had our fill with the current set of varieties, this would be sort of the next one that might come along and entice growers saying, okay, well, if I'm already growing those high enzymatic varieties, maybe it's worth switching over to this one because I may not have to deal with quite as much pre-harvest sprouting as maybe I have been in the past. So that's probably the one new trait that I see coming along, and we're maybe pretty close to having that out in a variety that has got everything else attached to it there. Yeah. So maybe I'll leave it there. It might be close for time, but if you've got questions, I'm happy to answer them now or later if they occur to you later on. So basically it's a matter, you're right, it's just combining, when I look back at the material that we got this from, it was a variety that had sort of more of that pre-harvest sprouting level of a Churchill, Copeland, with some higher enzymatic. So it's just a matter of combining those things and then screening for it. So what we try to do in terms of screening for it every year is we try to harvest a site that's sort of in their ideal conditions, so it hasn't been rained on prior to harvest. We don't obviously always get that every year, but when we can. And then to leave another field as long as we can and hope that it gets a little bit of rain before harvest. And so if we have lines that are being grown under those two conditions, we can actually look at how that rain has impacted the line. And so those lines which are impacted less by that rain event, that's essentially how we select for this high quality plus pre-harvest sprouting tolerance. So it's a matter of just trying to put parents together. We haven't really tried to study this in detail in terms of what's going on genetically. We know that there's a couple of regions in the genome that do have some connection to pre-harvest sprouting, but in the past, those genes have been causing too much dormancy. So basically maltsters are pretty picky on this point. They want to have stuff that they can take off the field relatively quickly and malt it within a couple weeks. They don't want to have to wait till Christmas to malt it. So what we're finding is that some of the genes that induce some level of dormancy or pre-harvest sprouting is too much, and you're having to actually wait several months before you can actually malt them. So It's kind of one of these things where it's just, again, like I said before, it's not a sort of a single gene trait. It's probably a whole lot of things going on in the barley there. Can I say that I've been part of a variety that's come along right now? Yeah. So Churchill would be one, Fraser as well, and then on the feed side would be something like Durango. Yeah. And if you do forages, Renegade would be the one. Yeah. And if you do Hollis barley, there'd be a few in there too, but not too many people grow Hollis barley. So, yeah. Cool. Easy crown.
All right. Thanks very much, Aaron.